Okay, I'm back with quiz 16 applications of quadratic functions. This is version 2.0. It's October 18th, 2021. Again, roughly about a year since I did the original one of these. And again, the biggest difference, just like with the homework counterpart, is that I've decided to go with these not using the TI-83 calculator, instead using the Desmos platform, which is a lot more flexible, a lot more manageable, easy to use, just superior in every respect. So let's go for it. Number one. Okay, this is one of those square box problems that we encountered with the homework. And once again, we're going to set it up so that we can do it. It's going to be, again, one of these type problems. And remember that you're going to have to add some dimensions on. So this one, it looks like it's 8 inches on each side. So just like we did before, I'm going to put 8 inches here, and here, here, and here, here, everywhere basically. Okay, just to keep that memory here. This looks like a rectangle, but it's meant to be a square. It doesn't matter as long as you remember that. And remember that the volume situation is volume is equal to the area of the box times the height of the box, which in this case is 8. So this basically is 8 times the area, and that is equal to 4,232 cubic inches. That's volume. So to get the area, which is square inches, we're going to divide everything by 8. Okay, so dividing 4232 by 8 will give us a 5 into 32 is 5. 8 into 23 is 5 again, I think. And 8 into 72 is 9. So if we're right, 559 should be a perfect square. Let me do a quick check before I do that. 4232 divided by 8 gives me 500 and oh, I made a mistake. 529. That would have been a big mistake. So I'm going to erase that part and replace it. So instead of 559, I can't erase here apparently. I have to do it this way. Go here and erase. That's going to give me 529. And I know that's going to be the side times the side. It's a square. So 2 lengths will give me 529. It's the same thing. Square root it. So 529, raise it to the power of 0.5. You can see that's a perfect 23. Okay, according to the calculator. So that means that this length here is 23. But remember that I also have to add the 8 on each side to get the box that originally, or the cardboard that this originally came from. So it's going to be 23 plus 16, aka 39 by 39. That's the dimension of the original piece of cardboard, and that's what this question is asking for. So we're going to give it that. 39 here and 39 here. Easy. Okay, so we got that one. We're taking care of that. Let's move on to the next problem. Next problem is, okay, it's a rocket problem in metric units. If you remember from the homework video, I recommended that you create templates in Desmos for each of these types of problems. So I'm going to go to that and look around until I find my template for this particular problem. It's probably not this one. There it is right there. And just change the details. So negative 4.9 stays the same. That's gravity. 277 now instead of 208. And 409 instead of 248. So 409. This is going to probably throw this off the screen, which it did. Remember also from the prior video that the shift key will drag it down to size, so you can see what you need to see here. I would make it so that I can see the right hand side too. It's probably going to ask us when it touches the ground or goes into the sea, and it does. It splashes down right away. The rocket splashes down when we have the y equaling 0, or in this case it's going to be 0 at 57.97 seconds. I'm going to write exactly that, and it may give you a hiccup with the decimal places, but that's going to be correct. Now, where does it peak? That's the key word here. Is going to be up here. It looks like it's going to be 4,323 feet, but give it the decimals just in case. 4323.745, and let's see what happens. 4323.745. The thing that's dangerous is that you don't know, you never really know what dimensions it's going to be asking you for. So I'm gonna round this up to a 5 and see if it'll take that. 2 decimal places seems to be safe. Okay, it took it. I can move on to question number 3. Okay, this is a new one. We haven't had this one. Have we? No, we haven't had this one yet. Okay, this is an interesting problem because we're going to have to do something different that we haven't done before. This is going to be using a linear equation that we're going to turn into a quadratic. So in some ways, it's similar to the area problem with the fencing and the river and the whole thing. Okay, but it's going to be a little bit different in some respects as well. So I'm going to copy this into my whiteboard so we can play with this idea. A baseball team plays in a stadium that hosts 64,000 people. With the ticket price at $10, the average attendance is 29,000. When the prices go down to 8, the average attendance rises to 32. Okay, assume that attendance is linearly related to ticket price. That linearly is a key word. It means straight line dimensions, right? So we know that to be true. So we're going to use that here, and I'm going to find a key space for this and paste this in. And let's make it bigger so we can see what we're doing here. Okay, I think we're ready to play here. Now, the first thing you have to do is figure out the linear equation that's going to generate this problem. So we're going to have to make a quick in and out table where X is the ticket prices and Y is the spectatorship. So at 10, we have 29,000 people. But when we go to 8, the attendance goes up to 32,000. Okay, the slope here is plus 3,000 for every drop of $2, and we can now simplify that to a slope of a negative 1,500. So that's part 1. Part 2 will be to put it into the equation. That'll help us figure out what the equation would be. So I'm going to do it using the point slope method that we had before. And that's going to give me a new thing to work with. So y minus, let's say, let me pick 10, I guess. It shouldn't matter. It'll be the same thing. Oh, no. Y minus 29,000 is y1. 29,000 is equal to negative 1,500 parentheses x minus 10. Okay, where x is 10, x minus x1, y2 minus y1, and now we just need to solve this out. So y minus 29,000 is equal to distributive property negative 1,500 x plus 15,000. Okay. I think that's right, 15,000. Everything looks cool. Okay, now we need to add 29,000 to that side. So y finally will give us an equation of negative 1,500x, and then 29 and 15 is 44. So remember to add this together. So you get 44,000. That's the equation that we need to use to solve this problem. So once again, get the rate of change. Get your slope from that, right? From here and from here. Negative 3,000 divided by, 3,000 divided by negative 2 will be a negative 1,500, dividing by 2. And then you put into the equation. So you need this one. And unlike the fencing problem, the quadratic equation will be, if to maximize revenue, we have to know that it's going to be the formula that you have here, multiply it with x. Okay, that's revenue formula, and this revenue is r times this, so x times this. So we're going to multiply this whole line by x. That's going to give us our quadratic equation of negative 1,500 x squared plus 44,000 x. Okay, and now we're looking to maximize that, so we need to go to the graph to do that, and we're going to put in exactly the way we see it, the y equals. Okay, that's the quadratic equation. So I need to find my template that's going to allow me to do that. It's probably, yeah, close enough. I guess I can work with that. That's a box problem. I don't know if I need that one or not. Let me just make sure I don't have one already laying around. Nope, nope, and no. So I'm going to use that after all. Okay, so I changed the order. I'm going to put it back into its regular order. So negative 1,500x, just to demonstrate that it would work. Negative 1,500x plus 44,000x. 44,000. Oops, sorry. 44,000x. I do have to make this into a quadratic. I did forget that part. Let me fix that now. Now you can see a curve. It's really skinny the way we see it right now. So shift and hold and shift and hold and shift again. And we don't see the top, which is what we want. So we want to drag it down until we see that top. That's our peak. We're looking for the peak revenue given ticket prices. And it looks like in this case, that happens where, let's say, right about there. Okay. So when prices are $14.67, we get our maximum attendance revenue of 323,000. So I'm going to put that in and see if this works. So 14.67 was the ticket price that I think is going to maximize our revenue. Let's hit. Okay, great. We got that right. 2 more and we're done. All right, so this one is, okay, gravity, 121 feet per second at 16 feet. It's in imperial units, so we're going to look for the template that lets me do that. That would not be this one. It won't definitely be this one. It'll be this one. Negative 16x squared plus the 56 is going to be changing to 121, and the initial height is 16. Now, the scale of the new curve is off, so we have to drag it back so we can see the entire thing, because we generally need to see both. Okay, when will the height be 35 feet? We're going to tackle that second like we did before. When will the object reach the ground? Recommendation, make that seconds right away so you don't forget to do it. Okay, now once we've done that, we can go to the rest of it. So at 0, 7.69 seconds. 7.69 seconds is when this thing is going to reach the ground. When will it be 35? Remember to do that thing I told you where you're going to make a system of equations of y equals 35 feet. And that's going to happen twice. It's going to happen here at 0.16 seconds. It's also going to happen here at 7.4 seconds. You want to put both. Okay, so this is going to be 0.16 comma 7.4, and that should do it for this problem. Hit submit. We got that right. I think you again, I keep saying it, Decimals is way better for these exercises than the TI calculator. It's just a lot easier to use it. Okay, and then we do end up with a fencing problem. Looks like the same kind of thing. It's a river problem. It doesn't give us the picture this time, but that's not a problem. We can do that ourselves. So I'm going to make the pen, and then I'm also going to, where's my tool for this? Hang on. Is it here? Yeah, it is. It's just further down. I'm going to create a line that will represent the river, right? Because this is the river. On this direction, this the river, and that direction, we don't need to worry about that part of it. We can ignore it. So all we really need to worry about is the other 3 sides. So again, it's just like what we did before. We don't need to worry about this side at all. All we need to worry about is the x here and the x here. Remember that the dimensions are going to be 100 minus the x, or 100 minus 2x. Area is length times width, and we're going to multiply 100 minus 2x with x itself, and that's going to give us our quadratic of 100x minus 2x squared. This one's actually so easy you could probably do it in your head, but just to illustrate that you don't have to, I'm going to go back to Decimals, and I'm going to go to, where is it? Where's the one I'm looking for? Is it this one? I guess I used this one. 100x minus 2x squared, or negative 2x squared, since I already have it like that, minus negative 2x plus, okay, 100x. Now, the thing that happens this time is that you just can't see it the way things are. The graph is way too out of proportion, so we're going to need to shrink the dimensions down so we can get a look at this. You can see it's super flat. So by raising this up, you can see that the y-axis numbers are getting lower and lower and more in proportion to the problem, and we're going to drag it to the right so that we can see the entire thing. All right, and it looks like the maximum area happens at 25. When x is equal to 25, we get 1250 square feet. Okay, so if x is equal to 25, remember, I'm going to have to bring this back again. When x is equal to 25, okay, that's another 25. That's 50. 100 minus that 50 will give you 50. So this is your dimension on this side and your dimension on that side. The length is the longer side. So what you're going to have to put here, it won't matter to me if you get it wrong. You get another shot at it. But this should be 50. And the width should be 25. Okay, that sometimes you play a guessing game with that until you figure it out. But that's what you should put in. And the dimensions are, what is it? 1,250 square feet. Oops, I put it in the wrong place. 1,250 square feet. Hit submit. We got the answer right. That is the last of the problems. And I hope you get value out of this video. Let me know what you think in the comments if you find these videos useful. If you have any suggestions to improve them, let me know that too. Okay?